Hi everyone, this lesson is for Algebra 2 Honors students. This is Chapter 6, Lesson 613 of the Logarithmic Chapter, Day 11. We are today discovering or going over the add multiply property for exponential functions. So let's get started. First though, we're going to do a little review, and last time I saw you, we talked about one-to-one functions and inverses. So we're going to review both of those. So if a function is one-to-one, then its inverse is a function. Check. If a function is one-to-one, you can do the horizontal line test, meaning it's not going to cross through two different places. If it does, if it intersects two spots, it's not one-to-one. The domain of a one-to-one function is the range of the inverse. That is a very cool feature. So today, for this problem here, we're trying to find the inverse. That's what f of -1 is. That we're trying to find the inverse. So this equation, which is f of x. So the first thing we're going to do is we're going to rewrite this, but we're going to replace f of x with y. So this is going to be y is equal to, and this is x plus 3 all over 3x minus 12. And then once we have that, now what I want to do is we're going to switch x and y, because that's how you find the inverse. And then you switch x and y, and then you solve for y. So switching x and y, we get x equals y plus 3 all over 3y minus 12. So now we've switched our x's and y's. Now we have to solve for y. So the way we're going to do that is we're going to cross multiply first. And so on the left, we're going to get y plus 3 times 1 is y plus 3. On the right, x times 3y minus 12. And in doing that, we're going to distribute this x. So we get y plus 3 is equal to 3xy minus 12x. I'm going to move this y over to the other sides because ultimately we want to solve for y. So I need to get the y's on the same side and then factor out that y. So moving this over to the left here, I'm going to get y minus 3xy. And taking this 3 and moving it to the other side, I get equal to -3 and then minus 12x. Factor out the y, so let's do that. So we get y times 1 minus 3x is equal to -3 minus 12x. And lastly, get y by itself. So we have y equals -3 minus 12x. And that's all divided by 1 minus 3x. And do not cancel, just leave it. And the last thing that you would do is you would take this y here and you would replace it back with the f of -1. So my final answer would be f of -1 of x, which is the inverse of f of x, is equal to -3 minus 12x all over 1 minus 3x. And again, you are not solving, you are not canceling those x's, you're not canceling any 3's, you're not doing any of that. You are not to do that. This is your answer, so leave it. Okay. This one says use compositions to determine if the following functions are inverses of each other. If these are inverses of each other, what ends up happening is that you would get x for both of the answers. You have to get x. X is your answer. If you get x when you plug both equations in, then you have an inverse. They're inverses of each other. So we're going to check that out. So the first thing we're going to do is we're going to plug f of -1, this right here, into the x for here. So in doing that, this whole quantity gets put in there for x. So what that means is, it looks like this. f of -1 of x is equal to, and then 4 times, and so this will be 4 times, and I'm going to put this in blue. So I've got 1/2 x minus 7/4, and then add 7. Don't forget the add 7. That's this part right here, right? And then this is all over 2. So let's simplify. That's all we're doing is simplifying. 4 times 1/2 x is 2x. And then 4 times -7/4 is minus 7. And then I have this plus 7. And all divided by 2. So we know that -7 plus 7, these two are 0. So I end up getting 2x over 2. And that reduces to just x. So far, so good. Okay, so now we're going to do it to the other way. So we're going to plug in f of x into f of inverse of x. So we have, this is how you would write it, f inverse of f of x is equal to, and so now I'm plugging f of x, which is this here, into that little x there. So we get, so let's see, I get 1/2 times x, and I'll just put that in green this time. So we get 4x plus 7 all over 2. And then lastly, we have minus 7/4. Okay, and we're going to keep these separate. So I'm going to do this. So I'm just going to multiply this across here. 2 gets multiplied by 2. That's it. So we get 4x plus 7 all over 4 minus 7 over 4, which I can combine because my denominators are the same. So that gives me 4x plus 7 minus 7. 7 minus 7 is 0. Those go away. And I get 4x divided by 4, which is x. Right on. So therefore, that means therefore, the functions are inverses of each other. And that's what you just discovered. You know, another way that you're going to see that too, by the way, is one of these equations will be listed as f of x, and then another might be listed as g of x. They're not always going to be, say, hey, here's f of x and here's f inverse of x, right? They're not always going to be like that. So today our learning target is just basically, we're going to use the add multiply property. And fun fact, there are multiple ways of finding the exponential equation, because that's our job, is to, big ticket item. I want you to find the equation. That's what you want to leave here from. That's like the big objective, to find the equation of the exponential function. And yes, you're using the add multiply property to decipher if it is an exponential equation or not, but you ultimately have to find the equation. So we're going to get to that. And I do like this because, yeah, don't use pen, okay? All right, so the general equation of an exponential function is f of x is equal to a times b to the x power. It's exponential, see the x as the power, that's exponential. So we are going to start off just saying, hey, here's just an equation, 3 times 2 to the x power. And see how they use x here and x here? The textbook always does that. I personally do not like that. So I would take anything like that and I would just replace it by like a dot. Maybe it doesn't have to be that big, but yeah, just a little dot right there. So you would list a short table of values for this equation. So you would plug in numbers. Like if you plug in 0, you get 2 to the 0 power, right, times 3. So that's 1 times 3 is 3. So these are just me plugging in numbers for this equation, all right? And yes, you can use your calculator, type this equation in and get to the table, and I'll show you that later, but that's what we're looking at for that. What do you notice about this equation? And that's ultimately what I want you to think about. What do you notice? And hopefully you, like pause the video, get some takeaways, think about what you would say, and then turn it back on. But what you would notice is that 0 plus 1, I'm adding 1 to the left. So every time on these, from here to here, I'm adding 1. From here to here, I'm adding 1. And then each time, I'm adding 1. Each time. On the left, I'm adding 1. But on the right, let's see, I'm adding 3. I'm adding 3. I'm adding 6. Okay, so that's not right. Because realistically, you're looking for a constant. All right, because if this is an exponential function, which we know it is, I guess because it says it is, and also because we know 2 to the x power, what you do on the left means you do something else on the right. And they don't necessarily have to be the same, because if they were the same, maybe it's linear. Okay, so what you're looking for, something on the right. So like, I would take the 2 numbers, like what's 6 divided by 3? Okay, so that's 2. Let's try from here to here. So 12 divided by 6, that's 2. Oh, look. 48 divided by 24, 24, also 2. So what you're looking at is this, that every time that 1 is added on the left, that the value of f of x is multiplied by a constant 2. And so that is your add multiply property. Boom. If it's add multiply, okay, then it has to be exponential, because they're not always going to say, hey, here's an equation, and by the way, this is exponential. You're going to have to decide, is this exponential or not? And the way you figure out if something is exponential is that you can add on the left the same number, the constant number. Could be 1, could be adding 2, could be adding 3, whatever. It's constant. Adding something on the left and multiplying by something on the right. And that's your add multiply property. Okay, so this is the theorem. If you have an exponential function, and this is what this is, exponential, then, right, you're adding something on the left yields a multiplication of something for the f of x on the right. And so adding a constant to the value of x multiplies the f of x value by a different constant. And so that's the add multiply property. So that being said, let's do this equation. Okay, it says calculate the values of f of x. I didn't give you an equation. Your job is to use the information, and first, yeah, we're going to find the equation, but not yet. First, we're going to draw the graph, and we're going to get our values here because I didn't give you an equation. What I did give you was the points in this form, which you need to be able to take and say, oh, 3 is 100. At 3, 100. So this is x, and then your result. Remember what f of x is. F of x, this value of f of x, right? F of x is y. And then we're plugging in values of x, that's x, and then our result is y, so that's xy. Also gave you 580. And so what I would suggest that you do for this is just, you need to come up with the multiplier, or in the other case, if I'm going up, it's a multiplier. If I'm going down, you're dividing, right? So let's just start with the 100. And if I divide that by 80, right, I get 1.25. Use your calculator to check my work. And so what that's saying is, if I take 100 divided by 80, I get 1.25. So now I'm going to take 80 and I divide that by 1.25. And that value I should get is 64. So this next value here should be 64. And you should see like the decreasing value. And then I'm going to take 64 and I'm going to divide that by 1.25 again. I'm going to get 51.2. And I could even do it one more time if I wanted to. Totally fine. Let's do it one more time and move this down. And if I did it one more time, what that would give me is 51.2 divided by 1.25. And I believe I get 40.96, and that's 979. So I'm adding by 2, 3, 5, 7, right? I'm adding by 2, so that's 11. Now, going the other way, though, instead of dividing, I'm actually multiplying by 1.25, right? If I took 80 and I multiplied by 1.25, I get 100. And then 100 times 1.25 is 125, right? Yep. And then 125 times 1.25, that's my -1, is giving me 156.25. So these are the values that I get after I found my multiplier / divider. You have to be able to figure out what the value is, because we know we're adding 1 to the left. No, actually, sorry. We're adding 2 to the left. So we know we're adding 2 each time to the left. But on the right, from here, we're dividing by 1.25. And if I'm going up, I'm multiplying by 1.25. Additionally, I want you to plot these points. That's what your job is to do. Draw the graph. Okay, so you plot points. And I know this doesn't go up to 125, so you're just doing an approximation. So we have like 3, let's say this is 3, and then let's say this is 100 here. So we'll say that's 100. And so this is 3. And at 5, so 5 is here, and that is, let's see, 80. So that's less. And let's see, we had 7, and that's 64. But then we had, let's see, at -1, or at 1, we're at 125. So it kind of looks like my graph is doing this, okay? Which, realistically, I mean, could that be a parabola? Could that be, something else? We know that this is exponential because they told me that it varies exponentially. If that is not obvious right from the start, then they need to tell you that so that you can see it. But at the same time, if I can see, they didn't give me all these numbers here, right? So I'm assuming that I would just do the same thing. Otherwise, how would I know that it was exponential, right? Okay, so you end up getting this graph, which kind of looks like this. It is exponential, and it keeps going up like that. So we did the graph. So at the next step, your next step, after you find the graph and after you can use your multiplier, your next step is actually to come up with an equation that works. Okay, so I'm going to actually show you how to do that by hand first. And it says, given the 2 points, right, we have 3, 100, and 580. Your job is to come up with the exponential equation. All right, so yeah, you do need to know this by hand. It definitely is important to know this. Remember, this is x here, and this is y. And so we're going to plug this into this equation for our exponential equation. But we're going to plug in both points, because as you can see, I have a y, I have a, I have b, and I have x. So once I plug my numbers in, right, for this one, so I get, let's say I get 100 is equal to a times b to the x power. Notice that I actually have two unknowns. And when you have two unknowns, that means you need two equations. So luckily, we have 2 points, right? So let's plug this point in. So we have 80 is equal to a times b to the 5th power. Two equations. And so what I'm going to do for this problem here is I'm actually going to divide. And I'm going to flip-flop the equations, because I like the higher power on top so that it subtracts and I don't have to deal with negative numbers. So what I'm going to do is divide the two equations, and doing that, so I'm going to rewrite this one here on top. So I'm going to say 80 is equal to a times, okay, let me write that better. Sorry about that. So here we go. We're going to go 80 is equal to a times b to the 5th power, and I'm going to divide that by the other one, which is 100 is equal to a times b to the 3rd power. And so what ends up happening here is that when you divide, right, 80 divided by 100, right, so you get 80 divided by 100, a is going to cancel out. And so this cancels out with this, and that makes 1. And then remember, the bases stay the same, right? Bases, if you can divide, bases stay the same, and then you subtract the exponents. If you were to go x to the 2nd times x to the 3rd, that would be x to the 2 plus 3. But when you're dividing, they actually get subtracted, not not added. So that's going to be b to the 5 minus 3, which is b squared, and that's going to equal this 8 divided by 10, which is 0.8. And now what I'm going to do is I'm going to take the square root of both sides, and in doing that, I'm going to take the square root of, so second square root, the answer, is equal to 0.8944. So b is approximately 0.8944. Okay, so that's my b value. And so now to find the a value, I have to plug it back into one of the equations. So I'm just going to take the top equation. I'm going to say 100 is equal to a times b, which is 0.894. And, you know, the more values you put here is better, of course, but that's to the 3rd power. So now we are going to take this number here to the 3rd power, and I'm going to divide it by 100 divided by that answer to get a by itself. And so in doing that now, it's going to be 100 divided by second answer, but that value is to the 3rd power. Okay, let's see what we get there. 139, so a is approximately 139.75. So therefore, and this is how you write the final equation, right? Your f of x exponential equation for this, problem that we've been working on is f of x equals a, which is 139.75 times b, and b is about 0.894 to the x power. And so now what realistically we can find anything that we want to find now that we have this equation that will work for the data that we have. Now, that being said, there is another way to do this, and there are other, definitely by the calculator. So if you have the TI-84 Plus, then what I would expect from you is to take that out, and I'm going to show you how to use that so that you can do exactly what we just did, but with the values. So I have the rules up here so you can see them. You're going to go to the stat button, edit, enter. We're going to plug in points. We're going to go to window, domain and range. And because remember, the window, especially when you're thinking about these numbers like 195 and then you're at -3, etc. Those, you've got quite a big difference between those numbers, and fitting on a little screen right there, can be a little bit trying. So get the calculator out, and we're going to go right to stat enter. So here's my TI-84 Plus. So again, just follow the directions on here, and I'm going to, whoops, what am I doing here? Yep, I'm going to move this over so I can see my points and be able to plug those in. Hopefully this will work. Okay. First I go to stat, and right away you're going to go to edit. That's the first thing that you're going to do. And so I'm going to hit enter. Now, if you have something here already, what you have to do to get rid of that is you go up to L1 and then you just hit clear. And then when you come down, that's gone. And again, you go up to L2 and you hit clear. So let's fill in the numbers now that we have L1 and L2 clear. So we have for X, let's see, we have the 1, -1, -3. So we'll plug those numbers in. So we have, let's see, 1, enter. We have a -1, -1. Oops, that they didn't like that. So I'm going to go to that. Roll down. You can't type in a minus sign for a negative. They just do not like that. So you have to put the negative. -1. I'm just going to keep going down, and then I'm going to go -3. So -3 and go down. And then for those three numbers, I'm just going to fill those in right now. So for 1, I have 125. Going down, I have 156.25. I have 195.3125. And I'm going to go back over. I'm going to hit R3, enter, and 100. Underneath 100 was 80, and then we had 64, 51.2, and 40.96. And then over for the 80, we had 5. Then 7, then 9, and 11. All right, so from here, we plugged in our points. Then you go to window, and you need to make your range in your domain. So like for X, that's your domain. So for X, our lowest point looks like it's -3. And so I'm going to go for my minimum for X, I'm going to say -5. And my max looks like it goes, oops, oh, I did that again. Sorry, definitely not used to the negative signs. Okay, so delete that. So it's got to be negative, what did we say? -5, and then going down for our max, 15 is going to work because I think our highest is at 11, at a scale of 1. And then for Y, our minimum, let's see, looks like it's 40. So I'm okay with 30, and then our highest was what, 195. So we can make that 200, and that should work. And so now I'm going to hit Y equals, because you need to make sure that you're on plot, because we are doing our first plot. So make sure that that's highlighted. Just hit enter, and it's highlighted. And now all you have to do is hit graph. So let's see what happens to our graph. I don't see it. So let's see, window, go back to my window, and 15 minimum. Okay, let's go back to graph, or Y equals. Oh, I didn't put the plot is not on. So here we go, highlight the plot. So that has to be highlighted. I guess I didn't go off of that. Now let's hit graph. So there it is. So there's our points. And so that's our exponential, and that's our regression. See how it comes down? It's a decline. It's a regression. So the next thing we want to do is, because ultimately we already graphed this, right? We already know what this looks like. But we're going to go to, we want the equation. So you're going to go stat. Now remember when we started to put the points into the table, we went to stat and then edit. So now we're going to go stat, and I'm going to arrow over to this value here where it says calc. And then I'm going to go down until I find exponential regression, which is right there. I just passed it. Exponential regression, which is at 0. And you hit enter into that. And then what it's saying is, are you using lists? Yes, we're using lists. And just return through those. So enter, 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 and we're not storing it. We don't need to do that. And now I'm on calculate. Now it's going to calculate, boom. And there we go. Look, you've got the A is equal to 139, which is what we had in the previous, when we did it by hand. And then the B is equal to 0.89, which is also what we had. And so that's using the TI-83. So that's how you would do that. Now I'm going to show you how to use the TI-NSPIRE as well. So I want you to be able to do that. Let's see, what is this down here? Oh, this is just telling you exactly what you're going to see, which is what we just saw. So let's go to the next screen because we want to do this again, and the TI-NSPIRE is slightly different. So we're going to put in the same values, and given that we're going to put the same values in, and then from there, I'm just going to copy those so I actually have them, and then use the TI-NSPIRE. So let's do that next. So here's my TI-NSPIRE. The first thing that we do for this one is we go to menu. So we're going to click on menu and, oops, that's not what hit add lists and spreadsheets. Okay. And so this is going to get me to this blank screen, right? And so I got to type my numbers in again. But the one thing that's different between the TI-NSPIRE and the TI-83 or 84 plus is that for the TI-NSPIRE, you actually have to label your values. So go all the way up to A, and you need to label that. So I'm going to call this just X, and I'm going to call B, I'm going to call that f of X, just like that. That's what I'm going to call it but you could call it time and distance, or you could call it whatever, you need to call it, but that's how you have to label that. That's like super important. Okay, so then we did that. We're going to put our values in. So I'm just going to go down the road at what I have. So I've got 3, 5, 7, 9, 11, and then I have some negative values, right? I've got 1, -1, and I've got -3. Okay, and so I'm going to go back up to the top, and I'm going to type in my numbers. I have 100, then 80, 64, 51.2. I've got 40.96 for 11, check. For 1, I have 125. For -1, I have 156.25. And for -3, I have 195.3125. All right, and so once we have this, we plugged in the points. Okay. Now we go to hit the, while we are on our stat plot here, you go to menu and you go down to statistics, and then you go across to, oops, not that, stat, okay, hold on, let me do this again. So we go to, let me escape here. Okay, so again, we go to menu, we go to statistics, stat calculations, and then you roll down until you get to exponential regression again. Right there, let go, click. And then now we have to type in our values. So you're always going to have something here, but what you need to do is click on here. And I know that for my X values, I called it X. And for my Y values, I called it f of X. And so now that's all I have to do. And I hit OK, and I'm done. because what they've just showed me here on, let's see, the right is my equation. I have to roll up a little bit, but here's my equation. Look, I've got a times b to the x power. I've got 139.75, and I've got 0.89 again. And so these are the values. Now, these values here are r squared and r. These basically have some values as to say, like, how reliable are your scores, etc. But we already know, because we were adding on the left and multiplying on the right, that that's the add multiply property. And because what we were adding was constant and what we were multiplying was constant, that means that it is exponential. Okay? Super. And that's how you do that. Super cool. And so I don't know, I somehow ended up way back up here. So here I am. And so we did everything we wanted to do here. I'm going to bring that down, and this is just showing you exactly what we did. And we were able to get the equation, the same equation again, using the TI-NSPIRE. So what I'd like to do right now is to do this, and this is another one that I'd like you to try. And so go ahead and do this on your own. And this is giving you information, hours and cells. And so I would pause the screen right now and then allow you to type your information in so that we can say about, this is just about growth in bacteria and cells and stuff like that. So the question ends up being, predict how many bacteria cells there will be in 10 hours. So, again, yes, you could do this by hand, and you can choose some 2 points and then come up with an equation. It's going to be a lot more accurate putting it into your calculator, definitely, but just try to do this and pause the screen and then come back as soon as you plug in those values. So what we're trying to do is come up with the equation that represents the growth of bacteria. So I ended up getting, when I plugged my values in, and you should type that in your calculator as well, I ended up getting the A was 20.5 and B was 1.92, let's say 4. Okay, so and let's plug those into our equations so that we could come up with an equation here. So we have, so we can use this equation to figure out what more information we need. So we've got, let's say, f of x is equal to a times b. So it'd be 20.512 times b, which is 1.924 to the x power. And so that would be our equation for the values that we have. Now, we have the equation, and now what it asks me to do here is this: predict how many bacteria cells would there be in 10 hours. So hours being my x value, that's the x here, I would plug that in, and I would say, well, I'm going to plug in f of 10 like this is equal to 20.512 times 1.924 to the 10th power. So use your calculator, and we're going to go 1.924 to the 10th power. I'm going to go equals, and then I'm going to multiply that by 20.512. And I am getting 14,258. So I get f of 10. So after 10 hours, now we are at 14,258. So that is really increasing, because see, after 5 hours, we were at 510 cells. And after 10 hours, now we're at 14,000 cells. So that is a huge increase, right? So this is what they're just saying. When you ended up doing this, you had your A as your vertical stretch, B is your, base rate of growth. R is not shown on the equation, but remember when we were talking about R being, is this a good correlation of data? For this problem here, if R is greater than 0.7, it has a strong correlation. But if it's less than 0.3, it has a weak correlation. So on ours, our value is 0.999. So for this right here, greater than 0.7, it has a strong correlation. So our value is 0.999. So this means that it has a strong correlation. So this is really a true and accurate graph. So what this is right here is, this is another question, different information. Which of the following functions, f or g, could be an exponential function? So remember, as these increase, so this looks like it's increasing by 6 on each one. Yeah, and that's constant. So what we need for both of these, for it to be exponential, an exponential function, is that it has to have a times value. The rate has to be the same every single time. It's got to be constant. So it can't change. So it's got to be, I mean, like, it's got to be pretty close to the same. So so I want you to take a moment and try to work that out, and figure out, well, how do I do, these values? And then restart 6.4. And just make sure that the values are the same. Okay, so assuming that you restarted, what you're seeing here is that for this one right here, you've got 6.40 divided by 1.73, you get 3.6. But then when you take the 25.12 and divide by 6.4, now I'm at 3.9. And then if you have that value that you just got and you divide again, you're at 3.2. So what's happening here, 8.2 divided by 225, each time you do this, these are a different value. These are pretty far off. Whereas on the right-hand side, when we took 6.4 and we divided by 1.73, we got 3.67, so 69, so that's about 3.7. Each time we got 3.7. So what that means is that this one right here is exponential, whereas this one is not exponential, and this could be something else, but only that one for g of x means that that's exponential. So if they don't tell you if it's exponential or not, and they just say, and they don't give you the equation for an exponential equation, then you can't assume that it is exponential. You actually do have to try. And again, you just take that second number and divide it by the first number. You're going backwards like this to try to get that. So for this problem right here, what we see is a biologist is researching a newly discovered species of bacteria. At time t equals 0 hours, he puts 100 bacteria into what he has determined to be a favorable growth medium. 6 hours later, so we're talking about hours and then bacteria. And so when I set up my equation, so far I have points. I have got 0 and then 100. And then 6 hours later, he has a measure of 450 bacteria. So that's 6 and then 450. So again, we want to find the exponential equation for this. And in doing that, we would say, okay, we've got f of x is equal to, and then you could change f of x to be b of x or whatever for bacteria, whatever letter makes you happy, a times b to the x power. And so, sometimes that's better, because by doing that, if I had said b, and we could use t for time, so why don't we do that? Let's just change that. And so we've got b of t, and then this will be a t over here. So we've got bacteria, we'll call it b of t, is equal to a times b to the t power, t being time. And time is our x. This is our time here. All right. So we're going to type this into our equation, or we can actually plug these values in, because right off the bat, if x is 0 or t is 0, right? T is 0, that's b to the 0 power. I already know a is 100. So, and then I could just plug that in. So this might be an easier problem just to do by hand to find the equation. But let's just do this. Let's get some practice on our calculator. This time I'm going to use the TI-84. We're going to go to, again, stat and edit. And remember, if you see something like already there, you have to go up L1 and clear, and then come back down. And then over here, I'm going to go over to the right. I'm going to go up, highlight that, clear that, come back down, and then now everything's nice and clear. So we're going to go type in our values. So our first point, what are our points? We have 0 and enter. And then over to the right, we have 100. And then below that, we have 450. And to the left, the other value was 6 hours later. So that's a 6. So once we have these values here, we want to plot our graph, just to see what it actually looks like. So don't just hit graph, because remember, you want to go to y equals first. Make sure that plot up on top is actually highlighted. And if it's not, then you have to highlight that, because you're plotting the points that you typed in. That's what you have to make sure that's highlighted. Secondly, we need to go to the window, because I still have the window from the last problem. And I see that for x, my x goes from 0 to 6. So, I mean, I could have the -5 there, totally fine. The max 15, I mean, I could even just make that go to 10. And then for y, my minimum is 100. So I'm going to actually make this go from 50, and then 450 is the max. So let's make that go to 500, just to make sure we can see everything in it. So now I'm going to hit graph, and this is what I have. These 2 points, because that's all the points that we have, but we do know it's exponential. Now, this is kind of important, because what now you do notice is that if you don't know that this is exponential, then, I mean, you very easily could possibly make this into a line. I could easily make this into a parabola or a quadratic if I wanted to. So you've got to make sure that, right, you know it's exponential when you're sketching it. Additionally, so you might need some more points. So now I'm going to go to stat, and I'm going to go over to calculations, and then I'm going to go down again to find my regression that's exponential. Hit that, and I'm using L1 and L2, so you just click through that, calculate, enter. There's my equation, which we already knew that A was 100, but we also found out that B was 1.2848. So given that information, I'm going to come back here. I'm going to plug in the values that I do know. Again, we know that A is equal to 100, and then we have the value of B is equal to 1.284. And so B of t, so this is my new equation, is equal to 100 times 1.284 to the t power. And then this is my equation. So now that I have this equation, I could actually find any kind of bacteria. I could be like, what's going to happen in 24 hours, right? So then I would say B of 24, and then I would put that value in, and this could be any time, right? 24, let's say there's this great, epidemic out there, and they're saying, hey, these are the 2 cases that we know. We know that this is exponential, and therefore what's going to happen within 24 hours, and then you can very easily calculate this on your calculator. Just make sure that you do this first, exponents be first before you do the multiplication. So that's it. You now know how to create an equation. Your homework is 1 through 11 odd. 1 through 7, different from the book, because yes, I want you to calculate values for f of x for 2 larger and smaller than the values that they give you. I also want you to plot the graph, so you're going to sketch it. And then lastly, which the book doesn't ask you to do, but I want you to do, and you need to do this for credit, is find the equation for the exponential function that they give you. And then problems 9 and 11 are the same directions as the textbook, so you can just follow that. So hope this helps. Thanks so much for watching.